Okay. So we found that the two solutions, these two solutions, were at pi over 6 and 5 pi over 6. Do those solutions repeat themselves? Yeah, how often do you think they repeat themselves? Every? Well, how often does the sine curve repeat itself? Every 2 pi. So won't you get a new set every 2 pi? Okay. Those are called general solutions. The ones you found on the unit circle, then you want to add multiples of 2 pi. Now, how do you show that the solutions are multiples of 2 pi? You throw an n in there. N is like 1, 2, 3, 4, 5, 6. So these solutions will repeat themselves at, when n is 2, they'll repeat at 4 pi. When n is 2, repeat at 4 pi. When n is 3, they'll repeat at 6 pi. 2 times 3 is 6 pi. So those solutions will continue repeating themselves, okay, because the curve keeps going. So if they ever ask for general solutions, all you have to do is add on, what is 2 pi called for the sine curve? Period, yep. So all you have to do for the multiple solutions is add on the period. Go ahead, Autumn.
What determines what n is?
N is any, in order to isolate the variables, first of all, they're on 2 different sides, okay? So how about we get the terms with the variables on the same side, okay? Are you guys all right with moving the constant term then to the other side at the same time? Can we do 2 things at once?
I think we should just subtract the sine terms.
Why subtract?
On the other side?
Oh, on this side?
Yeah.
We could, but then we're working with the negatives, okay?
Yeah.
So I think we're going to do the other side. So Leah, what are we going to do to get rid of this sine x right here?
Add sine x.
Add sine x. And what we do on one side, do on the other side. Everybody good? All right, Max, what's 1 sine x plus 1 sine x? 2 sine x plus root 2 equals 0. Okay. Let's use the idea of isolating the variable. So in algebra 1, I would make them box in the term with the variable. Jasmine, how do we get rid of plus root 2? Very good. Very good. So now we have 2 sine x equals negative root 2. All right. Isolate again the variable. Now this time box in sine x. And Haley, how do we get rid of the 2? Divide by 2. Okay. And now we have sine x equals negative root 2 over 2. Does that sound like a number that would be on the unit circle?
Yeah.
Yes, it would. Okay, so go to your unit circle. Find where sine is negative root 2 over 2. So in quadrant 1, okay, quadrant 3 you say? At what radians?
5 pi over 4.
5 pi over 4, and where else?
5 pi over 4. 7 pi over 4.
And 7 pi over 4. All right? Sine at 3 pi over 4? Sine it, yeah. Okay, so 5 pi over 4, 7 pi over 4. Okay? And if we write them as general solutions, it would be 5 pi over 4, 7 pi over 4, plus 2 pi times n. Any multiple of 2 pi. The answer will repeat itself. All right, how was that one? Not so bad? You are master solvers then. Example 3. Then the term with the variable, we're going to get the box by itself by adding 1. Sounds delightful. So now we have 3 tan squared x equals 1. Divide by 3, so box in tan squared. divide by 3, divide by 3. Everybody good? So now we have tan squared equals 1/3. Okay. Mason, what do your solving skills tell you to do to get rid of a square? What's the opposite of squaring? Square root. Okay. Everybody good? Square root of anything squared is just itself. Remember, when you're solving for a squared, you have to, that tells you to get two answers. How do we get two answers out of this? Plus or minus. Square root of 1 is just 1. Square root of 3 is square root of 3. Okay? Is that allowed, Hannah, to have a square root of 3 on the bottom? No, ma'am. So we're going to rationalize. And we're going to get tan x. What does it equal, Brianna, when we rationalize? Very good. Okay. All right, let's consult our unit circle. We want all the places where tangent is √3/3, either positive or negative. Where is that, guys, in quadrant 1? Where's tangent √3/3? Pi over 6. So now let's reflect it into quadrant 2. Here the tangent would be negative √3/3, but that's what we want, right? Either positive or negative. So far we have pi over 6. We have 5 pi over 6. Where are the other two? Raise, please. Where are the other two, Autumn? 7 pi over 6 and 11 pi over 6. Everybody get that? Does that make sense? Pi over 6, 5 pi over 6. 7 pi over 6. Let's start not writing general. Let's just list the answers. So 5 pi over 6. Oops, I missed pi over 6, didn't I? Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now, here's what happens on the test, is that people forget that you can get plus or minus, and they end up having just, where is it also positive? They end up having just those two answers because they forget the plus or minus on front. And then you're going to cut off half the problem is what you're going to do. So guys, don't forget your plus or minus in front. Okay? All right, not so bad. Now, never try to factor an equation until it equals 0. So the equation has to equal 0. All right? Nat, what would you like to do to make this equation equal 0? You want to move the left side to the right or the right to the left?
Right to the left.
Yeah, so how do I get rid of 2 cotangent x? Very good. So now we have cotan x cosine squared x equals, oops, sorry, I lost my minus 2 cotan x equals 0. Good. Natalie, we have 2 terms. Here's a term. Here's a term. Do you see anything we could factor out of there? This term doesn't have a cosine. Yeah, let's factor out a cotangent here. Yes.
Could you just combine, could you just make negative cotangent x? You just subtract from the sides?
They can't be like terms only because this one has a cosine squared with it. So, nice thought. It's a good thought. So now we got cotangent x. Remy, what's left in the parentheses?
Cosine squared minus cotangent.
These are going to cancel.
Oh, so minus 2.
Minus 2 equals 0. Now, from your good old algebra solving days, there's an algebra rule that says if A times B equals 0, Wouldn't it make sense that one of these is 0? Because if you multiply two things together and you get 0, one of them is going to have to be 0. So let's split this up, and let's say cotangent x equals 0. Okay? And let's say cosine squared x minus 2 equals 0. Okay? And how about for cotangent x, we put 0 over 1. Is that all right, guys? And why am I doing that? Because I don't want to talk about cotangent on the unit circle. I don't have cotangents on my unit circle. I have tangents on my unit circle. So Rachel, tangent is the cofunction of cotangent. So they're reciprocal functions. So go ahead and reciprocal 0 over 1. What does that come out to be? 1 over 0, which is undefined. Okay? Now we have to find the spots on our unit circle where tangent would be 1 over 0. So let's look at the top two quadrants. Pi over 2, it would be 1 over 0. Okay? And where else is tangent undefined? 3 pi over 2. Very good. So pi over 2, 3 pi over 2. Now maybe that's only half the answers because we have to go over to the other side. Okay? Miss Leah, how am I going to get cosine squared by itself? Add 2 to both sides. Excellent. So cosine squared x equals 2. Okay?
Don't you have to square root here?
So now we're going to,
Square root.
that's our next step. So we're going to square root, and we're going to get cosine x equals, and how do we get the two answers out of there, gang? Plus or minus square root of 2. Okay? Somebody got their calculator out? I didn't bring mine over. Anybody got what square root of 2 is? Approximately. Approximately 1.4. Okay? Now, one thing we know for sure is that on our unit circle, do you see any just square roots of 2's? No. So there's a problem there. Okay? What's the problem with 1.4? No, that's okay. You can what? Don't need to. But there's a problem with 1.4. Think of your cosine graph. What's the problem with 1.4? Is what? Pi? No.
It wouldn't be 1 tip marked up, it would be like 1 and 4
Right. The cosine graph, the highest point is 1. The lowest point is?
-1.
Will it go above 1.4? No. Okay. So this one? No go. We're not getting anything from there. That's not possible. Okay. So